So the topic 5.2, which is about the radioactivity. In this topic, you will learn the concept of radioactivity, the type of radioactive radiation such as alpha, beta, and gamma, then the decay curve and the half-life, and how we can use these radioactive isotopes, the applications. So this is a sign. Whenever you see this sign, it means that the substance is radioactive. This is a symbol used for the sign used for radioactivity. And what is the meaning of the radioactivity or radioactive substance? Radioactive substance has a tendency to emit out radiation or the particle, like emission of the energy, radiation, or the particle from the material. We call that as radioactivity. But why the material is emitting out these particles? Because what happened? Naturally, the elements which are having atomic number more than 82, like above lead. So naturally, the element which are having atomic number more than 82, their nucleus is crowded. Like lot of particles are there, so many neutron and protons are there. So the nucleus is crowded, it is having so many particles in a small space. And because these protons, neutrons are neutral, but the protons are positive like charges, and like charges repel each other. So the nucleus find it difficult to hold these particles inside, as there are a lot of particles, like the nucleus is populated. This is not an atom, whole atom. This is just a nucleus I drew. So the nucleus is so much populated that the nucleus not able to hold these particles inside. And when the nucleus is not able to hold these particles inside, how it can gain stability? By emitting out these particles. And when the nucleus is emitting out these particles, it can emit out in three ways. One is known as the alpha, another one is known as the beta, and the third one is known as gamma. So emission of the radioactive radiation or the particle from unstable nuclei due to the large number of the nucleons. The nucleus is unstable, it cannot hold these particles, so it tend to emit out these radiation or the particle, and we call that material as radioactive. And this radioactivity is a spontaneous and a random process. So radioactivity is a spontaneous or a random disintegration or decay of unstable nuclei by emitting out radiation such as alpha, beta, and gamma. What is the meaning of spontaneous? Spontaneous means we cannot trigger this, we cannot change the material. The amount of radiation which the material is emitting out cannot be changed. Like example, say there is a material which is radioactive and it is emitting out radiation such as alpha, beta, and gamma. So this process is spontaneous. Spontaneous means cannot be triggered by external factor, cannot be influenced by external factor. So if I supply the heat energy to this material, it won't change the amount of radioactive radiation coming out. So if the radiation which are coming out from the material are not affected by external conditions, so we call that as spontaneous. And what is the meaning of random? The term random means there is no order. Like example, you have a nucleus, first emit out alpha, then emit out beta. Then what will be the third radiation it will emit out? We cannot predict. Why we cannot predict? Because this process is a random process. There is no order. We cannot say first is alpha, then beta, then gamma. Maybe it might be first gamma, then beta, then alpha, or might be first beta, then alpha, then gamma. So it cannot have any order. It can emit out radiation in any way. So the spontaneous and the random process of emitting out radiation is known as radioactivity. So when the element is emitting out these radiations, It can emit out three types of radiation such as alpha. This is a symbol which you will use for alpha, the beta, and the gamma. Now, what is alpha decay? What happens when the particle is emitting out alpha? So in alpha decay, what happened? Like example, as I mentioned, the nucleus is populated. The nucleus contains lot of proton and neutron. So that unstable nuclei emit out two protons and two neutrons. When two protons and two neutrons are coming out from the nucleus, that emission is known as alpha. Alpha can be denoted by a helium nuclei or a symbol for helium, which is He. So whenever an element is emitting out alpha, what we'll observe, this is a general equation for alpha decay. The atomic mass will decrease by 4 and atomic number will decrease by 2, and this will be the symbol for alpha. So as you can see here, an element which is having a nucleon number 240 and atomic number 94, it emit out alpha particle or a helium nuclei. You can also use this symbol. Instead of writing He, you can also use the symbol for alpha. So if it is 240 and 94, when it emit out alpha, alpha means two protons and two neutrons. So when two protons and two neutrons will come out, how much the mass will decrease, because the nucleon number is a sum of proton and neutron. So the mass will decrease by 4. So that's why 240 minus 4, so it will be 236. And the atomic number will decrease by 2, because atomic number is the number of the proton. How many protons are going out? Only two protons are released. So in terms of proton number, it decreases by 2. So if originally it is 240, it becomes 236, and the atomic number is 94, it will turn to 90. Another example, as you can see here, an element which is 230 and 90. So if it emit out alpha, what will be the change in the mass? Because two protons and two neutrons are coming out, so the mass will decrease by 4, and only two protons are there, decreases. So that's why the atomic number decreases by 2. Same way, another element 238 and 92, when it emit out alpha particles, what will happen? The mass will decrease by 4 and the atomic number decreases by 2. So remember this alpha decay. So alpha particles are actually two protons and two neutrons which are coming out from the nucleus. So in exam you'll find they ask to complete a equation. So how to complete a equation? If there is an alpha decay, the mass should decrease by 4 and atomic number should decrease by 2. So as they mentioned here, a radon 222 nucleus decay by emitting out alpha particle and turn into polonium. Complete the equation. So radon convert into polonium. So this is a symbol for polonium, Po. And there's an alpha particle. So this is a symbol for alpha particle. 4 and 2 you can write, or you can write He. Both ways are correct. You can write like this, He42, or you can write a symbol for alpha and then write 4 and 2. Now what happened when there's an alpha decay? What happened to the mass? The nucleon number, it decreases by 4. So if originally it is 222, 222 minus 4, so it will turn out to be 218. And what happened to atomic number or the proton number? It decreases by 2. So 86 minus 2, so it will be equal to 84. So this is how we complete the equation for emission of alpha particle from the nucleus. So as you can see here, a nuclear equation shows a decay of plutonium to an americium and a beta particle. We will discuss this part, what is beta particle, but that is not related to the question right now. State the quantity that is represented by letter Z. So which quantity is represented by letter Z? The letter Z is representing the atomic number, or we can also say the proton number. How to work out the value of the Z, that we will discuss in a beta decay. But right now it will be 94 because beta decay part is still left. So we'll discuss that. So this is 94. But the next part, americium nucleus decay by emitting out alpha particle. That's the second part which. So complete a nuclear equation. So americium nucleus decay by emission of the alpha particle to neptunium nucleus. So the symbol first we write for neptunium, that which is N and P, and it emit out alpha particles. So symbol for alpha particle is 4 and 2. Now what happened? As we know, whenever there is an alpha emission, atomic mass will decrease by 4. So it is 241 minus 4. It will turn out to be 237. An atomic number decreases by 2, so it will is 95. 95 minus 2, so it will be 93. So this is the emission, like americium turned into neptunium by emitting out alpha particle. And whenever there's an alpha emission, alpha particle means 2 protons and 2 neutrons are coming out from the nucleus. So the atomic mass will decrease by 4 and atomic number will decrease by 2.